Okay, so this is just a couple of videos going through the practical exercises for the Tuesday class of week 2. This is all about introduction of the tidyverse, and it really ties in quite nicely with the data camp course I assigned. So try to, maybe at least look at that before the practical. So as per last time, we can have external libraries into R, and all this line is basically doing is if we don't already have it installed, checking using the required function, then we install it as a package. And then library puts it into memory. And we're going to use two packages. We're going to use dplyr, which has all the data manipulation for the tidyverse, and we're going to have ggplot2 that has all the plots. And don't forget to get in the right directory. I think most people got it that last week. But if you don't, just a reminder, if you don't know where your directory is, just go to session, set working directory, choose directory, find wherever you've set your files on the computer, and then click open, and you'll actually get the code to paste in the R environment. This little squiggle here is just really, this is just a shortcut for the documents directory. That's why this in line 7 is not exactly the same as this, but they both work exactly the same. Okay, so we're loading in a data set as per last week. You can load data in different formats. This is a comma separated list, so the data file is literally just the values separated by commas, self-explanatory. And strings as factors equals true just means that we have some kind of string data, and we just want to treat it as like a nominal or ordinal variable. So let's just load that in. And then we can use the view to look at it as if it was like an Excel spreadsheet. And you can see this is the data set. So we have lots of information in the house. You see there's lots of things, the zone, lot frontage, whether there's an alley. So there's lots of kind of categorical data, the neighborhood it's in, its condition, the building type, the house style, quality ratings. Then we have lots of area information. So this is a decent data set. And then we have somewhere, we've got to actually move on because it only shows 50 columns at a time. In column 82, we actually get the sale price. So this data, we're not going to use it for that purpose today, but this data set is usually used for checking out regression models because we're trying to predict the sale price. Okay, so str views the columns, give the column format. And, you can actually, let's just have a look at the factor levels. So let's just have a look at the, which one should we do? We have so many, I'll have to make a decision. So let's just do the land slope. So let's just go back and housing data. We're going to look at the land slope. And you see that it's a factor, and it defines, we have 3 levels. So there's like gentle slope, moderate slope, and severe slope. That's just the slope that's within the lot. Okay, so how many rows and columns does the data set have? Well, we did all that last week, so think of some of the functions we used to get the size of the data set. Of course, you could cheat and just look at what you saw in the view, but look back for week 1 for that. Now, let's just have a look at using a table. Again, we did something similar last week. So if we put something in a table, we're basically summarizing by 1 or potentially 2 categorical variables. Here, we're just going to do 1. We're going to look, and we can see that these are, you've got the 1 family, the 2 family, the duplex, the townhouses, and the number of, I think this is executive townhouses. So the majority of houses, as you would expect, are single family houses. Okay, so now let's do the actual tidyverse stuff. So the first thing to think about is this is the pipe function. And all the pipe function does is it allows you to take a data set, so we have housing data, and then apply multiple different functions in order. So we could say pipe it to filter, and then we could pipe it to something else. These two, 31 and 32, do exactly the same thing. The only difference here, we're using the pipe, and here we're passing the first parameter is the actual data set. So rather than passing the data set here, we just use this little 2% and a greater hand sign, which is sometimes called the pipe. Now let's just look at view this one. And you can see that basically this is all the data of houses that were sold in 2010. Yeah. So every year sold is going to be 2010. So we've done a sub data set. And again, you want to be using what we did in week 1 just to remind it, how many rows are in a data frame, how many columns are in a data frame. I gave you a few functions to look at that. Remember, we also had the mean. We also had the median and median functions. So if you're not quite sure, I want you to kind of build up your knowledge. So I'm not going to give you absolutely everything, but all these things were actually done in the first practical. Okay, so now let's look at one family houses in 2010. And with filter, you can actually do multiple kind of criteria. So here we want one family houses and we want years sold in 2010. We just put a comma in between these two. And then we have housing data sub. Let's just view it again. And let's just go. So we have 2010, and then somewhere we should just have the one family, the type. It's such a big data set. Here we go. Building type is all one family. I guess I'm almost helping you cheating here, but we can see how many houses we have. And there were like over 2,000 houses in the original data set, and now we only have about 270. Okay, so we can actually use a few more functions in the tidyverse. Remember we used the order function last time. This is just very, very similar. So we're going to arrange, and we can arrange on sales price, and we can arrange by descending or ascending sales price. So now let's just look at view of the housing data. And we go to the end for sales price. And you can see the highest. So this is like, Iowa 10 years ago. So there aren't any, Iowa between 2006 and 2010. So there aren't any house prices costing multiple millions of dollars. This was the most expensive house price sold in Armies, Iowa in this time. So this is the most, you get the most expensive houses up here. And we can just, if we do a range without desk actually defaults to ascending. So let's just see if this is updated. Yeah, and the cheapest house was $12,000 These must be absolutely almost burnt down houses, and then the next one's $30,000 to $40,000. Okay. So the next thing is mutate. And what mutate does is it basically allows you to create new variables. So imagine, we want to find a common metric in real estate is like, the price per square foot. We don't have that in our data set, but we can actually do it by calculating the sales price divided by the number of feet. So we're going to do the price per square foot. And again, we're piping it to mutate, and that's just creating a new column. So mutate, you just do it like an equation. You put new column equals, and then whatever your combination of the old columns. So this is sale price divided by greater living area. And then we actually pipe it to a range. So you can see now there's advantages and disadvantages of this notation, but it allows you to do multiple steps in one line of code. And now we're going to do it by descending. So let's click run. Oh, no, actually, I need all 3 lines. Silly me. And now let's just view housing data. Let's go to the end. And you see they're now ordered by descending price per square foot. So in fact, the 755,000 didn't have the highest price per square foot. It might have been an absolutely massive house, which is why it was so expensive. but now they're kind of ordered in price per square foot. Okay, so the next thing we have is summarize. And what the summarize function does is it allows you to kind of get aggregate statistics. So we can find things, what was the mean sales price? What was the maximum sales price? What was the minimum sales price? So here we have for 2008, so we're going to filter like we did before, but this time we're going to do year sold is 2008, and then pass this to summarize where we have them. So this is a little bit like what you would do with a pivot table in Excel. We're going to have something called mean sales price, which is the mean sales price, median, max, and then min. Min, max, mean, and median are all kind of standard functions. So let's just see what it outputs. And there we go. It outputs, there's the mean sales price, the median, the max, and the min. Just be aware this is all in 2008. You know, say we could do in 2010, let's just do 2009, and we actually get slightly different values. So now we want to see if there's any kind of trends over the years. So what we're going to do is we can actually have something called group by, and that allows us that when we do summary statistics and we've grouped our data, it actually calculates the summaries for every one of our groups. So we're going to group by year sold, and now we're going to do the summarize exactly as before. And this time we're going to save it, and we're going to save it in something called summary stats. And let's just see what it's returned. It's returned as something called a tibble. Now, tibble is just a kind of a fancy data frame. It's really just the sort of data frame used by the tidyverse. The tidyverse functions all work with standard data frames, but if they're creating something new like here, they'll sometimes return you a tibble. And what you can do is you can actually just look at the data first. So you can see the mean, median, min, max, and min by year. So again, this is really, really like an Excel pivot table. So you can see the mean sales price in 2008 is 178,842. And we can actually see that the highest mean sales price was in 2007, which makes sense because the 2008 was the start of the big recession where the house prices really crashed. So we'd only have 5 years, but you can imagine houses rise up to 2007, kind of crash down to 2010, and then start recovering maybe in 2011, 2012. So to convert between types, you always use as. Usually for most inbuilt data types, it's as.something. You've seen me use as.integer before or as.numeric for a number. But here we're just going to convert this to a data frame. And you can see now it's your everyday standard data frame. You don't have those funny kind of lines under the first 3 digits of the numbers. We can actually, let's just do str on this new data frame. You can get the standard, we've got the standard column information, data frame, 5 observations of 5 variables, and then the different columns there. Or we can convert it back to a tibble. Now, no, this is a bit weird, but when we convert to a tibble, the tidyverse likes underscores rather than dots. So we do as._tibble, and let's just look what we got back. And here we got our tibble back. We basically just converted to data frame and back to a tibble. So we didn't do anything, but just to show you how this works. Okay, so now let's go to ggplot. Now ggplot, I don't know why the library is called ggplot2, but it is. ggplot allows us to do some simple graphics. Most ggplot functions have the same. Now, ggplot is very complicated. It will take you a while to learn it, but it has a standard pattern. The first thing is you pass the data set. Then you pass what's called the AES, and this is telling you what pieces of information you're going to use in the data set, usually in the X and Y coordinates, but sometimes for specifying things like colors or fills, outlines, things like that. Here we're just going to call X, we're going to have the living area, and Y, we're going to have the sale price. Then we usually have something defining the graph. So this one's G on point. And then we can pass some kind of extra aesthetic theme information. So I'm just going to say theme BW. You see, if I didn't do theme BW, we'd get this horrible gray background that I don't like. So all this is doing is here. This looks more professional. And you can see here there's a positive relationship between living area and sales price. Generally, these are the houses with really high sales prices of high living area. You've got a few down here that are outliers. These are probably houses that are very cheap but have a lot of square foot. They're probably in a bad neighborhood or a little bit trashed. But there is a general kind of, relationship between size and sales price. Now we can also set a log scale. Now sometimes if we have, say for example, we had house price. It doesn't in Iowa. It doesn't matter so much. But if we have house prices in like in New York City or Los Angeles, you might have a house costing $100 million, and that's going to kind of compress most of the normal houses in the graph, and the graph's not going to look very nice. So what you can do is you can kind of put everything onto log scales. So this time we set a scale X log, a scale Y log, and let's just have a look at this. And you can see now, if you look here, we have 30,000, 100,000, 300,000. It's not going up evenly, but you can see that we don't really have these outliers at the high end. Okay, and actually, I said, which one do you prefer? And I don't know why I did that twice. We'll actually remove that. There's no point to that second one. Now we can actually add extra things into our aesthetics. So we've specified X and Y. We can also color by building type. Exactly the same before, but we've added a color. And you see here, and you can see here it's not great because like nearly everything is a single family house. But interestingly, you can see the duplexes tend to be lower priced. And this is a student town, so it's a little bit like in Starkville. There's a few studenty areas, maybe a little bit run down, where it's all duplexes and where all the students live. And you can see like the executive house prices, they tend to be more expensive than the average house per area, but there's kind of a top limit. The really expensive houses tend to be single family houses. Now, there's something here. The next thing is called a facet wrap. Now, what we're doing here is, rather than coloring by building type, we actually specify facet wrap. And I don't know why it uses a squiggle. It just does. But you specify facet wrap and building type, and it's going to create us a little graph per building type. The option SciPen, if you give option SciPen with a large number, sometimes they will try and go to scientific notation. So say we have, what do I mean by scientific notation? 1E6, that's like $1 million. Sorry, 1 million. It's basically 1 times 10 to the power of 6. So to prevent it doing that, sometimes we set these options. But don't worry about it too much for the moment. Let's just see what we does with facet wrap. And here we go. We've got 5 different types of house, and we can actually plot for each type of house. And again, you still have this strong relationship with one family houses. Most of the 2 family houses are pretty cheap. Same with the duplexes are kind of in a range. And the executive houses, there tends to be with townhouses, there tends to be quite a, you don't have any really huge townhouses. And again, there's quite a strong relationship between the size and the sales price. Okay, so let's do a different type of plot. So let's go back to what we did before, where we were grouping by the years sold, and we had these summary values of mean, median, max, and min. So this is just, I gave it a different name, but it's what we created before. It's the table we created before. Now we're going to plot this, and we're going to have X years sold, and Y is going to be the median sales price. And we're going to do a line graph, G on line, and the point graph, G on point, and then we're going to do theme BW. And that's a very simple graph. So we basically have years sold and median sales price. So we can see again, we peaked in 2007, and then we slowly decreased into the recession. Okay, so let's do a bar plot. We want to do a few different types of graph. This time, we're actually going to group by the type of exterior. So we're going to do the same, but by grouping by exterior. And now we get all these values for each different type. This is a factor level with a lot of factors. We have asphalt shingles, asp singles, brick face, I guess that is. There is like a helper file with the data set which will explain all this. I really don't want a plywood house. I'm not sure that would be good. You can tell a stone house is very expensive, and maybe the stucco houses are just not in fashion because they're a lot. They tend to be a bit cheaper. But anyway, we have all that information. And we're going to do exactly the same. So our X is going to be exterior, Y is going to be the median sales price. But this time we're going to do geom_col, which is creates as a bar graph. So I need actually a big space for this. And we need to spread it out even more. But here we go. So we have the different exterior points. And you can see that precast stone, something imitate. I don't know why imitation stucco is expensive and stucco is low. But cinder block is the lowest and asphalt shingle is the lowest. So some of that's not surprising. Okay, so now let's do a basic histogram, the sort that you did in hopefully in one of your business stats too, probably did stats 1. Now, the thing is with the histogram, we're basically grouping one variable. So we're going to look at the histogram of sales price. We only need to send it an X. In fact, we'll probably get an error if we send it stuff we don't need. And we're going to use geom histogram with default properties. And you can see here this is the sales price. Now, most housing data is really right skewed. You get your median house price and you get a few more expensive house prices. So you can see things like wages tend to be the same. These tend to be like really right skewed data. So the next thing we're going to do is we're going to do all the stuff in stats 1. We're now going to do a box plot. So this time we're going to do it by building type. We're going to have a sales price Y, and we're going to do a box plot, which is geom box plot. And here we go. Now, with a box plot, the bottom of the line tends to be the minimum value, and the top of the line is usually the maximum value. And with exceptions, which I'm going to mention in a minute, and the 25th percentile is the bottom of the box, the median is the middle of the box, and the 75th percentile is the top of the box. So, 25% of the data is below the box and 25 is below. The height of the box, the difference between the 25th and the 75th percentile is called the interquartile range. Now, quite often with box plots, you will actually go from the top and the bottom of the box, and you count like 1.5 interquartile ranges. So we count this times 1.5, and anything above this value or below this value is considered an outlier. And we plot it separately as an outlier, which is why you see a lot of outliers on sales price. I mean, that's because we have a lot of very high value prices. So we could actually, we could play around a little bit. We could actually do a log. And there we get it's a little bit more less kind of squashed there, where we just do the log of the sales price. But I actually think it's probably better just with the actual sales price, because you're relating it to the actual sales price of the house. Okay, and that's it. That just goes through. Again, I've tried to give you most of it, but if it's something we did in week 1, I don't want to completely give it you. I want you to be able to think a little bit and, slowly build all the tools that you have when you're programming R. But hopefully that should explain most of what we're going to do in class. The second video, I'll do an analysis of the educational data set. But that's not one that we will have time of for the practical exercise. But again, it's a nice set of analysis on a different data set.